Hello, algebra students. Here's another one of those where you might not see the relationship to algebra, but we do have an algebraic method we learned for solving this. Let me show you what I mean. Rubio's Toys is designing a new line of toys, Squisho shapes. Each toy will be constructed of clear, flexible plastic and filled with 700 cubic centimeters of brightly colored slime. Ooh, sounds fun. They plan to produce cylinders, cones, cubes, spheres, and rectangular prisms. Hey, there's some names of some 3D shapes, some 3D solids. After the first round of production, the manufacturers find the toys become too firm when filled to maximum capacity. Uh-oh. They modify the design to allow for maximum squishiness, using 660 cubic centimeters of slime per toy without changing the dimensions of the shape. The redesign reduces the amount of slime per toy by what percent? Oh my gosh, so much info. What are they asking me to do or to find? Well, that's in that last sentence, huh? The redesign reduces the amount of slime per toy. We knew that, but look at this. By what percent? They're asking us, this reduces the amount by what percent? They're asking us the reduction is what percent. Now you might say, what percent of what? When you're looking at percent change, it could be an increase, a decrease, reduce. There's a lot of ways they can say it, but it's always out of the original. Percent change is always out of the original. So the reduction is what percent of the original is what they're asking. And I like phrasing it that way because it leads us right to that method that we said we could use. We said we could set up proportion equations to solve percent problems. And so what are you going to do? You're going to do a fraction out of that relationship. The reduction, the amount it was reduced. The decrease is another way to put it, or sometimes I just say the change over the original. And you can set that equal to you can set that equal to a percent ratio, right? A percent is always a number out of 100. All right, let's go find the information we need to plug into this sucker. So first, the reduction. What do we know? Each toy, I'm reading up here in the beginning. Each toy will be constructed of clear, flexible plastic and filled with 700 cubic centimeters of brightly colored slime. Okay, so that's the original amount of slime per toy. And then, where is it? They modify the design to allow for maximum squishiness using 660 cubic centimeters of slime per toy. So I started at 700. I ended up at 660, but I don't want either of those numbers. I don't want starting or ending for the top of the fraction. I want the change, the reduction, how much it reduced by. Another way to think of that is the difference. And so I'm going to subtract to find that difference. If I had 700, I'm going to take away that 660. It went down by 40. The reduction is 40 cubic centimeter reduction. And that's always going to be out of original. Okay, so you might get confused. Do I pull the 700 or the 660? The 700 was how much it was originally. So when I talk percent decrease, I'm talking about the decrease out of the original. And that's going to be equal to some percent I don't know out of 100. And now that I have it set up like this, I can use my algebra methods that I know in order to solve percent problems. And the way we did it was by noticing that beautiful pattern that cross products are equivalent. Some teachers just call this cross multiplying, but that's why we can cross multiply, because cross products are equivalent. So 700 times P is 700P. And 40 times 100, the other cross product is, let's see, 4 times 1 is 4. And 1, 2, 3 zeros. 1, 2, 3 zeros. And cross products are equivalent. Don't lose your equal sign or you lose your power to solve. Awesome. And now last step, let's just get that P alone. So P is being multiplied by 700. I'll divide it away to get rid of it. Multiplying and dividing by 700 are opposites. They cancel. P's alone, just like I wanted. And 400 divided by 700. Oh, sorry, 4,000 divided by 700. It's 5.7, yada, yada, yada. And you might want to try to convert it right now, but you don't have to, because when you use this lovely proportion method, we already accounted for the fact that it was out of 100. So you don't have to move decimal places or do any work to convert it. This is the percent, so it's about 5.7%. All right, B is the correct answer. Tricky, but doable, doable. We got this. We have an algebraic method in order to deal with this. Certainly not the only method, but the method we focused on this unit. All right, you guys, strong work. Super proud of you. Happy learning.